For this tutorial, we'll go through the process of creating an allograph grayscale image file that aligns with your original color source to create tactile elevated prints. In this procedure, rather than start with simple gradients in Photoshop, we'll build 3D objects aligned with the color source and apply a grayscale gradient. This will provide a strong base with tones to build upon at the 2D stage of creation of an elevated file. Before proceeding, make sure to review the intro video on this channel to familiarize yourself with the fundamentals of creating an elevation file. Open the color working file in Photoshop, and in the color settings, adjust the following. Select North America Prepress 2. RGB set to Adobe 1998. And CMYK set to US Web Coded Swap V2. With the file open, turn on gamut warning and make any adjustments to the colors at this point, so expectations are set for a physical CMYK color print. The source image for this project is quite simple in terms of geometric shapes, but remember to factor in all scenarios and gotchas when considering a more complex collection of geometry. For instance, in this architectural image, it seems simple at first, but when taking into account foreshortening and barrel distortion, creating objects can turn into a rabbit hole. Sometimes creating tones in Photoshop is best, or at least mixing of the two techniques. This 16-bit image is 25 by 16 centimeters at 300 dpi, and will have a maximum elevation of 4 millimeters. The features to be elevated with 3D objects include screw heads, rivets, metal blocks, the door handle, and even these overlapping copper sheets. Before starting, consider what will be the lowest part of the elevation. Due to the overlapping plates, this would seem to be the lower half. However, it will in fact be the bottom of the recessed screw heads here. Similar to the technique in other videos, create a plane with the same aspect ratio as the color source image. Divide it in half and extrude it enough to allow for the recessed screws. However, the recess in the screw head needs somewhere to go below the plane, so make sure to create holes at each location at this stage before proceeding. Adjust the control vertex to match the edges of each hole in the plate, noting where some screws are slightly out of place. Scale in the bottom of each hole so the screw head has a receding surface to blend to. At this point, let's consider what we're creating in the final output. A 2D image that represents a 2.5D version of a 3D object. We can't print undercuts, so right away we need to keep in mind that it's not appropriate to use fully three-dimensional representations of each object we know and understand. We can't see the axle of the door handle. Logically we know it's there, but there's no point in modeling it, and there's no point in making the handle fully round either. Let's create the base of this handle assembly to start. Draw out a rectangle with rounded corners and leave holes in those corners for recessed screws. Complete the shape as a sub-D surface and extrude it to create depth. In the color image, we see that the perspective only reveals two vertical sides. But in order to avoid walls here and here, we'll need to add two additional sides here and here. Drag out the control points in each direction to create an exaggerated angle down to this lower surface. Use a simplified technique to make the smaller rectangle here. This handle is up above the surface of the door logically, right here, but for the purposes of the print, the edge of the handle actually intersects with the door and blends into it. Creating a smooth blend between this curved surface and the surfaces here, here, and here would be quite tricky in Photoshop, whereas it's automatic in a 3D arrangement like this. Next, create the 3D handle with a round cylindrical shape, but cut away the lower half. The reason for this will become clear in the final steps. Move the surface so that the lowest control point just intersects the flat surface. Create a dome screw head with a recessed slot, ideally with the sub-D modeling technique, so that the object can be subdivided to a smooth state while still having simple control points to easily customize the shape as needed. For the sake of clearer visibility, and to better align the screws with the original image, place and align 2D shapes as guides for placing the screws. Duplicate and rotate each screw to match the 2D spline shape. Next up are these domes. Draw out a spline to define the curves and loft the shape. With these shapes going across the image, they change in perspective, so each needs to be scaled and distorted to match the color image. Apply a freeform deformation modifier and adjust each to match the change in perspective. It will be a delicate balance to get just the correct shift without creating a wall, getting it just right in 3D. Sometimes blurring in Photoshop is the easiest way to fix any possibility of a wall. Lastly, adapt the dome screw to create a flathead screw. Scale it to fit here between each dome, and duplicate along the row. Again, using 2D shapes aligned to each of the slots, rotate each head to match the color image. To make the elevation tones, create a standard shader with a linear black to white gradient ramp, using object XYZ coordinates aligned with the model's vertical axis. This will place black at the highest point and white at the lowest. And ensure the shader is set to self-illumination. With that in mind, look at the object from the side, and notice where vertices are dropping down below the flat plane surface. This will be the location of the whitest pixels in the final render. Make sure to bring all vertices above the lowest point with no outliers. When the shader is applied to all objects, the result is individual gradients over each object. To see one gradient over the entire assembly, attach all objects together. Now render from the camera view and consider any adjustments to balance the high points and focus the elevation on the main subject. For instance, if we want the handle to be the highest point, then undo the attach and move the handle higher than the domes, remembering to adjust the control points down to the base. Now reattach and re-render. That's working much better. In the before and after, notice how the darkness of the handle is similar, but the next highest point, the domes, are much lighter, as they were closer to the previous high point, whereas now they are about half as high compared to this new high point. With all adjustments complete, render and save this as a grayscale 16-bit TIFF. Open the original color image in Photoshop and apply an adjustment layer to create a grayscale version. And consider the tones and what they will give you in elevation. All these tones become shades of gray and will affect the underlying surface to a greater or lesser degree, based on how dark each is. In this case, the only areas that would benefit from the details in the photograph are the slight pitting of cast metal here and small dents and scratches. Open the grayscale rendered TIFF and paste the color image on top. Consider using a different blending mode, in this case soft light, with the opacity set to 20%. This will add subtle details to the pitted metal, but it's also placing unwanted undulations to the smooth domes and other areas that will be noticeable in the print. Set a mask for the layer to restrict this effect only to the door handle assembly, and here on larger dents. However, there are other small scratches overall that should be there to break up the surface and provide the appearance of a handmade object. To achieve this in the final print, duplicate the layer, invert the mask, and set the layer opacity to 15%. Now we get a consistent appearance for the whole surface. However, we don't want to see this undulation of the surface on the domes and screw heads. At the moment, the mottled shades of gray are breaking up what should be smooth. Add black spots to the mask to eliminate the effects of this layer from having any effect on these areas. At the moment, this layer's source is the basic color image, which has lighting effects as well as details. For best results, it's necessary to clone out all lighting effects on this layer. Otherwise, for example, the dark shadows will elevate up on the resulting print. Cloning can work for smaller areas, but it's best to use the pixel values in place. So for these areas of diagonal light, it's best to apply an adjustment layer, like with this levels layer and mask, to reduce the light effects. Return these gray layers to their previous settings, and save out the color and grayscale 16-bit chips. Using these, generate a point cloud preview with the image to point cloud converter to see how the process is working. Load the resulting PLY file into Cloud Compare and consider the results. Zoom in with the mouse wheel, and then adjust the point size by holding Alt and the mouse wheel, until the flat areas appear solid. Take into consideration the solid appearance of these points on the flat background surface versus on this rising slope. If you can see through to the empty world space, then it's possible the print will have a darkening of the color due to less material landing on the sloped surface. The larger the gaps, the more likely the color will print darker, but it doesn't need to be completely solid. The way to reduce the size of gaps around each point is to reduce the contrast in the elevation file, which reduces the slope. Here's the final print with a total elevation of 4 mm at the highest point. As we can see in the cloud preview, it's looking good. So the print is working, and the contrast between elevated areas and flat is large, resulting in an eye-catching effect. It's important to plan ahead with your projects, as more complex compositions like this will require pre-planning and a series of steps that rely on the previous decision. With these techniques and your skills in your preferred 3D app, you should have no problem generating the working grayscale file for your project. For further tips and techniques, check out the other videos in this series.